Hello everyone, welcome back to the channel. This is Neeli. I'm a first year student studying at Sri Venkateswara College of Engineering, Bangalore. I am currently pursuing my BE in Computer Science and Engineering. Today, in this presentation, we will learn some basic modular arithmetic such as divisibility, greatest common divisor, and properties of prime numbers. And then we will see its application in computer science background. Let's start with divisibility. If one integer, say n, divides into a second integer, say m, without producing a remainder, then we say that n divides m. It is denoted as n followed by a vertical bar, then m. Similarly, when n does not divide m, that is, it produces a remainder, then we say that n does not divide m. Also, if n divides m, there exists a q such that m can be written as q into n. The point here to be noted is the absolute values of both q and m are less than absolute value of m. For example, let us assume 4 here as n and 24 here as m. When 4 divides 24, it will produce a value that is 6. So that 24 can be written as 4 into 6. Here, both 4 and 6 are less than 24. Similarly, in the case of 5 divides 135, 35 can also be written as 5 into 27, where both 5 and 27 are less than 135. Here is the division algorithm. You can pause the video and refer to it. Moving on to greatest common divisor. If a, b and k are integers and k divides a and b, we say that a is a common divisor. Let us assume k as a set of integers that divides a as well as b. If d is the greatest in k, d is called as the greatest common divisor. There are several methods to find GDC of two numbers, including Euclidean algorithm, prime factorization, and using a GDC calculator. This is an example of finding GDC using prime factorization, and this by Euclidean algorithm. For better understanding, let's see a short clip for the same.
Let's start by breaking down 540 into its prime factors. The prime factorization of 540 is 2 to the power of 2 multiplied by 3 to the power of 3 multiplied by 5. Now let's move on to the prime factorization of 315. The prime factorization of 315 is 3 to the power of 2 multiplied by 5 to the power of 1 multiplied by 7. To find the greatest common divisor, we look for the highest power of each prime factor that appears in both numbers. In this case, the greatest common divisor of 540 and 315 is 9 multiplied by 5, which equals 45. Let's explore the Euclidean algorithm to find the greatest common divisor of 48 and 18. The first step is to divide 48 by 18, which gives us a quotient of 2 and a remainder of 12. Next, we take the divisor 18 and divide it by the remainder 12, which gives us a quotient of 1 and a remainder of 6. We continue this process, dividing the previous divisor by the remainder until we reach a remainder of 0. The last non-zero remainder is the greatest common divisor of 48 and 18, which in this case is 6.
Let us now see the properties of prime numbers. First of all, what is a prime number? It is a natural number greater than 1 that has no positive divisor other than 1 and itself. In other words, it has exactly two distinct positive divisors. Every natural number greater than 1 is either a prime number itself or can be factored into prime numbers. This is known as the fundamental theorem of arithmetic. Note: if a number is divisible by any prime number up to its square root, then it's not a prime number. Under basic prime number algorithm, first we have to check if the given number is equal to 2 or not. If it is, then the given number is prime. Otherwise, proceed to step 2. Check if the integer k is a divisor of n, where k should be greater than 1 and it should be less than n minus 1. If none of the values of k are divisor of n, then n is the prime number. Here towards the end of this video, let us quickly see some applications of modular arithmetic. First is hashing. Hash functions often use modular arithmetic to ensure that the resulting hash values falls within a certain range. This is crucial in data structures like hash tables. Second, cryptography. Many cryptographic algorithms rely heavily on modular arithmetics. These algorithms use the properties of modular arithmetic to encrypt and decrypt the data. In computer graphics, modular arithmetic is used to create periodic effects, wraparound navigations in virtual reality, and cyclic animations. Memory management. In computer systems, modular arithmetic is used in calculating addresses in circular buffers. This is particularly useful in situations where memory needs to be reused efficiently. With this, I would like to conclude the video. Thank you so much for watching. Stay connected.